Hello, this is Maria from Math Mammoth, and this is Mathy, my mascot. In this lesson, we're going to talk about significant digits. And you might ask, what are those? They're also called significant figures. And let's read the definition. Significant digits or figures of a number are those digits whose value contributes to the precision of the number. They're mainly used in the context of measurements or approximate quantities, rounded quantities. So here's an example. Let's say that you have a measurement, 3,700 meters. What's that? How long is it? Well, I don't know. It might be something that you might run, if you go running, jogging, you might run 3,700 meters, 3.7 kilometers. But what if it was 3,701 meters or 3,700.0 meters? We can see that each one of those measurements, they have a different level of accuracy. The last one is the most accurate. It is accurate to the 10th of a meter. Whereas 3,700 meters, we don't know how accurate it is. Is it accurate to the meter or to the 10 meters or only to the 100 meters? Maybe it's a rounded measurement. Maybe somebody originally measured 3,667.5 something and then rounded it to this. We don't know. So therefore in this 3,700, only the 3 and 7 are significant digits as far as we can tell. So it has 2 significant digits. Now it might have more if somebody tells us that, okay, I measured it to the nearest meter. Then we would know that it has 4 significant digits. Or somebody tells us that, well, I measured this to the nearest 10 meters. Then we would know that, okay, it has 3 significant digits. But if there's no other information, only 2. The next one here, it's accurate to the meter, right? So all 4 of these digits are significant. They tell us something about the accuracy. They contribute to the precision of the number. And in this last one, it's measured to the accuracy of 10th of a meter. So it has 5 significant digits. Now let's look at these ones. 0.6 kilograms. What's that? Mathy is asking. Well, we might need 6 of you, Mathy, or 7, to make 0.6 kilograms. It's not very much. 600 grams. And how many significant digits would it have? Well, we were talking about tenths and, such just before this. And this is 6 tenths. So only the 6 is significant. Only one significant digit here. 0.06 is the same. Okay, it is 6 hundredths and only has one significant digit. Only this digit tells us something about its precision. And the last one has 2 significant digits, 6 and 1. Here are the complete rules, and you will also find these in the Math Mammoth curriculum in the lesson. All non-zero digits are significant. 38.2 has 3 significant digits. And then zeros between other significant digits are also significant. 50,039, all 5 of those digits are significant. You can imagine that maybe it was a measurement and was measured to the nearest meter, 9 meters, 50,039 meters. And then non-decimal zeros at the end of a number are not significant. We just looked at this, okay, with our 3,700. 6,400 has only 2 significant digits. Decimal zeros in front of the number are not significant. 0.0038 has 2 significant digits, the 3 and 8. But decimal zeros after that are significant. They make it more accurate. And then in scientific notation, all digits in the multiplier, in the decimal part of the number, are significant. 5.40. So this number has 3 significant digits. Alright, now let's practice a little. You tell me, think about on your own, how many significant digits these quantities have. 170 feet. These 2. The last one is not, because we don't know. Maybe it was originally 165 and somebody rounded it. So only accurate to the nearest 10 feet. 45.0, all three are significant. This is more accurate as a measurement than just saying 45. 4.050 kilograms, all four are significant. 0.02 kilometers, only the two. 1.02 kilometers, all three. And here in this last one, scientific notation, all three. Next question is, which one of these numbers is the most accurate and which one is the least accurate, if these were measurements? Here 9 has one significant digit. How about these others? All of the others have more, so 9 is the least accurate here. 9.03, there's 3 significant digits. Here's 2, and here, yes, 0 over there. It contributes to the precision of the number, yes. So 4, and this one also has 4. So these two are the most accurate, equally so. Here our task is to round these numbers to the number of significant digits given in the parentheses. So 8 million something, but round it to 4 significant digits. So if we want 4, they will be these 4 that we will include. We will need to round it up because there's 9 here. So we will need to put here 5. Rounding to the nearest 1,000 is what we ended up doing. Here what will happen? 3 is what we need. 3 significant digits, so 9.1. And yes, 0 stays as 0 because here's 4, so we round down. We will not change this digit. The last one, to 2 significant digits, which will be this digit and this digit. Okay? 0, 3, 4, no, 5. Because 8 is the next digit, it makes the 4 to be rounded up to 5. Significant digits are used a lot when calculating with measurements. So let's look at some examples. If I calculate 2.9 centimeters times 3.6 centimeters, this could be an area of a rectangle, for example. And I get from a calculator 10.44 square centimeters. But I cannot leave the answer like that if these were measurements, because each measurement here is accurate to 2 significant digits. My answer here is 4. And if I multiply numbers, then the rule is that the answer should have as many significant digits as the number that had the least number of significant digits, the least accurate number in the factors. So here I multiply these two numbers, they both had 2 significant digits, so the answer also has to have 2. We round it to the nearest square centimeter, therefore, and just give it as 10 square centimeters. And 10.44 would only be given as an answer if we actually know that these measurements are more accurate than that, or that they are maybe exact numbers for some reason. The second example has $20,000 divided by 220 people. We can still think of these as measurements. Maybe you know they are fully accurate, but then again, maybe it's an estimation, for example, and the 220 people is not exact. Maybe in reality it's 218 people or 224 people, it's just an estimate. Or maybe the 20,000 is an estimate. And so from a calculator we get this kind of number as an answer, $90.9090. We have to round it, but how? Significant digits will help us know how. These 220 people, just by looking at the number, it is 2 significant digits. 20,000 could be accurate to the dollar, or to the $10, to the $100, or to the $1,000, or to the $10,000. We don't know how accurate it is, but let's just say that it is accurate to the $1,000, so that it is 2 significant digits. If so, then this answer here will be rounded to 2 significant digits and becomes $91. If we knew that this was accurate to 3 significant digits, would it change anything, and how? It would not if this number stays as 2 significant digits, because we will go by the least accurate number in multiplication and division problems. Only if we knew that this was accurate to the person, so to speak, or to the one person, then would we make this rounded to 90.9, give it as a more accurate value. Another place where we end up using significant digits often is in conversions between measurement units. Because you have one measurement, and then you convert it, and then you get a long decimal number, and then you need to round it. So here we have 4.6 kilometers, we convert it into miles. This conversion factor has a lot of significant digits here. This is what a calculator gives you, a long string of decimals. How do we round it? Since this was a division problem or a multiplication problem, in this case it was division, but measurement conversions always end up being either multiplications or divisions. So therefore we will take what had the least number of significant digits. Once again, it was this one here. The measurement itself had 2, the conversion factor had many more, and so we go by that. This final answer has to be given to 2 significant digits. So we round it to 2.9 miles. Okay, that's all. I hope this was helpful.